This is a quick video on how to calculate velocity on a curve. Today I'll be teaching you how to interpret distance time graphs and also how to use tangents on a curve. So here's the question. We will go through this question and I'll read out exactly how I would do it and the skills that you would need in the exam to attempt questions like this. So the first part it says is that a bus is taking some children to school. The bus has to stop a few times and the figure below shows the distance time graph for part of the journey. So I can see here I've got distance on my y-axis and time on my x-axis, and then I have lines and gradients showing the motion of the bus. First question is, how far has the bus traveled in the first 20 seconds? So in the first 20 seconds I can see from time that is about here, right there actually. I would go all the way up and on my graph draw a line horizontally, and I can see that it has traveled 100 meters. So the first part is 100 meters. It then says describe the motion of the bus between 20 seconds and 30 seconds. So I can see from my graph here, this is referring to this part here. I'll highlight there. And that part is a straight line. So a straight line in our case, what that means is that the object is stationary. And we can kind of interpret that here. If we look from 20 seconds, he's still at 100 meters. And at 30 seconds, he is still at 100 meters. So he hasn't moved. So we'll say that the bus is stationary. We then move on to our next part, which says describe the motion of the bus between 30 seconds and 60 seconds. So I have a choice. I have to choose whether it is accelerating, reversing, or traveling at constant speed. So we'll go back to our graph. I'll zoom in here. Now between 20 seconds and 30 seconds, we know the object is the bus is stationary. Between 30 seconds and 60 seconds, I can see that my line is curving upwards. So it's looking something like this. I don't want to draw here because I'm going to use that later on. So because it's curving upwards like this, I can see that my gradient, if I was to draw lines, I'll do that in a different color. That's a gradient there. It's another gradient there. And another gradient there. So I can see that my gradient is becoming steeper. Now we've learned in lesson that when a gradient becomes steeper, it means that the object is going faster. So if it is going faster, that means that our object is accelerating. And that would be the correct one there. We then move on to the next part of this question. What is the speed of the bus at 45 seconds? That's important. And it wants me to work out the speed. And it's saying here, show clearly on the figure above how you would obtain your answer. So I have to give the examiner a method in how I would calculate this. And I have to use the graph to help me. It's 3 marks. So I'm going to try and aim for 3 marks in this question. So I'll go back to the graph. I'll zoom in here. Now the first thing that we need to do is, the question stated that it was at 45 seconds. So at 45 seconds, I need to find that on my graph. I can find that here. If I choose 45, I can see is at this point between the 40 and the 50. That's about here. Make the pen a little bit thinner. I then work my way upwards. I use a ruler. You can see a line right there. Now, at 45 seconds, this is the part that I want to show you in this video. You need to be able to draw a tangent to the curve. Now, a tangent is a line that touches the curve very, very slightly, and it follows that curve's edge. So I'm going to try and draw it as close as I can to the curve and not move it around too much. you'd have to play around with your ruler a little bit. I'm going to draw my triangle like that. So I've now drawn a tangent to that curve. I'm going to use that as a triangle to create a triangle now. So I'll go across, and this will then help me calculate the gradient. So that is my triangle there. Draw the final line. I don't really need to. I have an edge there, but I will do it. Okay, so I've drawn my triangle now, and I now need to calculate the gradient. Now, I know that to calculate a gradient, you would use this formula. M represents gradient, change in y over change in x. Now we know our y-axis over here is defined as distance, so change in distance, and x-axis is change in time. So once I work out the change in distance over the change in time, that will give me what I'm looking for, which is speed. So I can see on my graph here that each box represents 5 meters vertically. And that's because I just look at the bottom, I can see that there is 10 boxes between 0 and 50. So therefore, if I do 50 divided by 10, that will give me 5 meters. So I can see here that this point is at 30 seconds, and I'll do that in blue, or in green actually, is at 30 seconds, and that is about, I draw my ruler, okay, along, that is 75 meters. So I've got one of the points now. I now need to do the same for the other point, which is here. So I can see that this is at 60 seconds, and this is, I count the squares, 1, 2, 3, 4, 5, 6, 7 squares above. So 7 times 5 will give me 35. So 150 plus 35 will give me 185 meters. Or I could have just gone across like I did with the 75 meters and calculated it that way. So I'll come back because I've got my information now. I'll go to my working out. So I can see that to calculate my gradient, which is speed, well, the change in distance was 185 meters minus 75 meters, and my change in time was 60 seconds minus 30 seconds. And we can see that with our graph there, 60 and 30, 185 and 75. And can you see I've corresponded it in the way where if I'm choosing 185 meters at the top, then on the bottom, I also start with the time corresponding to 185 meters. So if I put that into my calculator, 185 minus 75 will give me 110 meters. And then 30 on the bottom, and 110 divided by 30 will give me 3.66 recurring. Now I can see in the question that this answer, all the values that they've given to me is two significant figures, so I will leave this as 3.7 meters per second. Now, not everyone will draw their tangent exactly like mine. So you will have variation between answers, and so in the mark scheme, anything between 3.2 and 4.2 meters per second is a valid answer. We'll now move on to our next part, part B. So later in the journey, the bus is moving and has 500,000 joules of kinetic energy. So I'm going to highlight that again, that's a good piece of information. And the brakes are applied and the bus stops. So originally the bus was moving and now it's stopped. How much work is needed to stop the bus? So let's clear up a common misconception. Work done is the same as energy. So if you're traveling and you have a certain amount of energy, if you've stopped suddenly, you've lost all that energy. So all this kinetic energy has now been transferred to the brakes, causing the bus to stop. So in this case, the work done, simple one marker, is the same as in the original kinetic energy is 500,000 joules. Now the next part says the bus stopped in a distance of 25 meters. Calculate the force that was needed to stop the bus. So the first thing that I will do is I'll write down the formula which relates between work done, force and distance, or I'll write down the side, work done equals force times distance, aka energy is equal to force times distance. I know my energy because I've calculated it here. It's 500,000. So the first thing that I will do, and this is how I always construct my answers, write down the formula. First step, always write down the formula. Work done equals force times distance. Next thing that I need to do is substitute the values that I have into that formula. So I know my work done, i.e. the energy is 500,000. What I'm trying to figure out is the force. Don't know that. But I do know the distance is 25 meters. What I should have said was that here I should put a little d there. That's a good way to get into the habit of the question. Always highlight what you have and what you don't have. So I'll even highlight this here and say that is my work done. I then basically rearrange my formula. So this would give me 500,000 divided by 25, which would give me the force. If I put that in my calculator, that will give me 20,000 newtons. So, if you all try to attempt your questions where it requires a formula in this method, it will be very, very easy. So it's a 2-mark question, one for, I guess, writing down the substitution, and one for rearranging to get the answer. If in the exam you get the wrong answer, but you have that method of showing your substitution, you will at least gain 1 mark. And the final part of the question is, what happens to the kinetic energy of the bus as it is braking? Well, you can imagine that when a car moves and it brakes, the kinetic energy is being transferred because it's no longer moving. What does it get transferred into? If you were to touch the brakes after a certain while, from causing it to stop, it will be very hot. So the energy is transferred as heat. Energy transferred as heat to the brakes. And there we have it.